Welcome back, and today we are going to look at a question called product of array except self. So if we see here, it's a medium problem. Okay, interesting. Facebook, Lyft, Goldman Sachs. Cool. All right, so let's read the question. So this question is pretty fun, I would say. It's a kind of a fun question. So it says, given an array nums of n integers where n is bigger than 1, return an array output such that output I is equal to the product of all elements of nums except nums in the index of I. So for example, if we look at here, 1, 2, 3, 4, the output would be 24, 12, 8, 6. Why? Because here, for the first index, if you take 2 times 3 times 4, that is 24. And then for the second index, if you take 1 times 3 times 4, that gives 12, and etc., right? So then please solve it without division in O of n. Cool, awesome. And then later on there's a follow-up. But let's just look at the problem for now. Let's take this example of 1, 2, 3, 4. 1, 2, 3, and 4. Okay, so let's just not look at the constraint for now and think about how would we do it if we didn't have these constraints. So the fastest way that I can think of is we can just take the product of all these numbers. So what is 2 times 3 times 4? That's 24. So you could have something like prod, as in product, equals 24 because you just multiply all these numbers together. And then your output array would look something like this. Given these numbers from 1, 2, 3, 4. So what I do is I take the product and then I divide by the number depending on which index I am. So for example, the first one, 24 divided by 1 is 24. And then the second one is 24 divided by 2, which is 12. And then 24 divided by 3, which is 8. And then divided by 4, which is 6. And then that's it. That's your answer. And that would have taken O of n time because you're just going through it once to get the product and then going through another time to create the final array. So that's pretty good. However, the question says you cannot use division. So this is where the funky part begins. So how do we get the product of everything except for myself if I cannot use division? So there's one trick that we can do, and this is actually quite a popular trick in a lot of these interview questions, is by having a, usually it's kind of like a sum, a rolling sum of the array, but this time we'll do a rolling product or something like that. So let's just take this same example, 1, 2, 3, and 4. So what you want to do is imagine if you want the product of the whole array except for yourself. So what are 2 things that you can use that gives you the product of the whole array, but except for yourself? So what if we can do the product of all the numbers to our right multiplied by the product of all the numbers to the left, right? So for example, if I had this entry on 3, what if I know the product of these 2 numbers, which is 2, and the product of all the numbers to the right, which is 4, and then 2 times 4 is 8. What if we have that? So this is actually easier understood if we have a longer array. Let's just do 2, 4, 1, 5, 3, right? So imagine if 1, I want the product of this multiplied by the product of that. 2 times 4 is 8, and then 3 times 5 is 15. What if we have that? And then we just multiply this together. I can't do mental math, but 8 times 15 equals 120, I think. I might be wrong. I think that's it, yeah. It's 120. So you just multiply these 2 numbers together. So how can we make it like that? So what if we create 2 same data structure that records what we want to see? So here's what we can do. We can create a left array and a right array. Let's just call it L and R. And then we can initialize it by multiplying what is on the left. So the left one, the first one would be 1 because what's on the left of 2? Nothing. And then what you do is you just multiply these 2 numbers together and then you're going to get 2, for example. So that means on this index, everything that is multiplied use like everything, the product of the left side will be this value 2, right? So let's just do that again. And then for the third one, you just multiply this number and this number, which gives 8. And then you do that again. What's 8 times 1? 8. And then this one, 40. So let's see if that makes any sense. So the number 40 should represent the product of all these numbers. So is that true? 5 times 4 is 20, times 2 it's 40, times 1 is still 40. So that's great. So this works. So our array works. So then we do the same thing to the right side, where we start by 1, and then we take this number and this number, multiply it together, we get 3, and then 5 times 3, 15, like 5 times 3, 15, 1 times 15, 15, and then 4 times 15 is 60, right? Same thing. So then if we have these two arrays, it becomes really easy, right? Because the number that you want on your output, I'll call this O for your output, is you just multiply these numbers together. So this would be 60, because 1 times 60 is 60. And then these two numbers, 2 times 15 is 30. And does it work? Let's see, 2, that's 2. And then I do not multiply myself, which is 4. And then this should give me 15, which it does. As you can see here, it's 2 times 15, right? 2 times 15, and then you see 2, and then the product of my right side is 15. So you literally just multiply these together. Remember what I said? It's 120. Yep, 120. And then 3 times 8, 24, and then 40. Right? So that's really cool. So what is the complexity of this? So first of all, we go through the pass. We pass through the array once to build our left array. So that's O of n to build that. And then we do another pass, but from the right to the left. And then that's also O of n. And then what we do is we multiply the left and the right arrays to get the output array, which also takes O of n. And then, so we just add these together. It's technically 3n, which in the end, it's linear time. That's cool, right? So, and what about the space? How much does it take? Usually the space, we don't really, well, for this question at least, we don't count the output array. The output array is O of n, of course, because you have the output array. But if we don't think about that, then we use O of n because we have to create 2 separate arrays of size n. Awesome. Cool. All right, let me do a little bit of erasing. So there's actually another follow-up that says, could you solve it with constant space complexity? Oh, so by the way, let's go back to the question. Here it says that we can't use division. We did not use division here. And we want O of n time, which we did. And then now it's asking to do it in constant space. So this is also a kind of like a trick that people use. And the trick is that you have to use your output array as memory. So you're going to use that output array that they already give you, that they handed to you, and you're going to use that. So technically it's not really constant space, but because they don't count the output array, as you can see here, the output array does not count as extra space. Because it doesn't count, then you can actually use it to your advantage. So we're going to use the same concept as the left and the right, but this time we are just going to use one array, which is the output array, and then we're gonna fill it out that way. So it's actually the same concept. I'll just show you how you can do this. You could think about it a little bit, but here's how we do it. Now imagine we have the same array, right? And then what we want to do is we want to initialize just one of the array. And then, so this is the input, and then the output, let's just initialize it as 111. And the great thing about this array is that this does not count as does not count towards the extra space. So we're still in O of 1, right? And then what we want to do is we want to initialize this array. We'll make this the left array. So we're going to transform this array into, this is still the same array. So 1, 2, 8. So how did I do that? It's the same thing as I calculate the left one. 8, 8, and 40. Right, so now you have two arrays. You have an input array and an output array, right? So now you already have one. Now the other thing that you want to do is you want to remember the right side. You want to remember what's the sum of the right side. But what we realize is we actually only need one value because we're not going to reuse the old value later. So let's have a variable called r. And let's initialize this to number 1. And the reason why is because we're actually going to iterate through this array, this input array, onto the right side. And then we'll keep the variable r kind of like how we use the output array for the left side, but instead we're going to just keep one variable to remember what the product is from the right side. Super cool. So what we do is we will use this array and this array and also this variable to compute the final output array. So how do we do that? So what we're going to do is we're going to iterate on the opposite side. So instead of going from left to right, we're going to go from right to left. Okay, so then now that I cleaned it, what we can do is we're going to start iterating this way, right? And we're going to use the input and output array to calculate it. So what we're going to do is for the first one, we're going to start here. We don't need to do this one because this one is already the right answer because we've already calculated the left array, and the left array, as you can see here, it's going to be multiplied by 1 anyways. So we're going to start here. So what we're going to do is we're going to use r, and then we are going to multiply it with 5, and that will give us a new r. Because imagine if you're iterating this way, you're going to multiply by this 1, 3, 15, like that, right? So then r, what we're going to do is just like how we did it with the r array, we're going to keep computing it using the input array. So r will become 3 because we multiplied it by 3, right? So we multiply r by 3, so then the new one is r3. Okay, so now that we have r3, what do we do? What we're going to do is we're going to multiply 8 because we are here with the new r, and that would give us 15. Oh no, sorry, 24. My math sucks. Okay, and then after we finish recording this, it's no longer 8, it's 24. We're going to do the second run. So now we are here. So r, the new r, would be 5 times what our r is already. So then it's going to be r equals 15. And then we do 15 times 8, which is 120, I think. 120. Awesome. And then we're going to do it a third time. And then we're going to take this number, multiply by r, which is r equals still 15. And then 15 times 2. Like, do you see the pattern? We're actually doing the same thing here, right? Here on top, we're multiplying the same values. It's just that we're not keeping the r in an array, we're keeping it in a variable. So then same thing, 15 times 2 equals 30. And then lastly, let's use pink. We are here, and then we're gonna multiply 4 by 15, which is 60. Yeah. And then r becomes 60 now. And then 60 times 1 equals 60. And then there you go. This is the final array. Ta-da! So yeah, so in here we would have had, like in the previously, we would have 2 arrays and we're just gonna multiply together like this. 30, 120, 24, 40. And then yeah, this gives us the same thing over here. God, that's a lot of colors. Whee! All right, so that's pretty much it. So let's see what it looks like during the coding. All right, so like I said before, you want to initialize the output array, which I call result or res, times length of nums. So it's the same size. And then what we want to do is we construct the left array. We use the output array and we make that into the left array. So for 1 in range, we're going to start from the first index, not the 0th, because we want to multiply by our current index minus 1. And then it ends here. So then, okay, we're gonna multiply from the back one. Yeah, multiply that plus the input array, which is 1. Cool. And then, like I said, we're gonna have r. r equals 1. I could call it right equals 1 just to make it easier. And then we're gonna iterate from the opposite direction. So for I in range, length of num, usually you do -1 if you want to start from the end, but we're going to do -2, just like how we did it here, because we want to leave one space behind. And then we're going to go backwards, so -1, -1. And then remember the right one. What we want to do is we want to multiply it by the index plus 1 of the input array. So right equals nums I plus 1. Yeah, so we're going to multiply by ourselves like that. And then the result is basically the resulting array, which is actually the left array, times r, which is the right side of the product. So let's do that. And then you just return the result. And then that's pretty much it. All right, cool, done. And ta-da! Excellent. So yeah, so that's pretty much it for this problem. I hope this was helpful. And yeah, this is a very fun problem, very common technique where you create either a rolling sum, like you keep summing up. Is it really called rolling sum? Cumulative sum, sorry, like a cumulative sum, prefix sum, but this time it's prefix product. All right, cool. Thanks so much for watching. See you in the next question.